Hello everyone, I'm Poonam Sharma, your science teacher. Welcome you all. Practice questions or discussion of question answers of metals and non-metals chapter. The children, in previous class we have finished this chapter, metals and non-metals. Now in today's session I'll discuss very important questions according to exam point of view and how will you present your answers. Now let's start with the important questions of metals and non-metals chapter. So first question which can be asked in exam is, due to which property of metals are metallic foils prepared? And the answer is due to their malleability. As we know that metals are highly malleable in nature. We can easily convert them into sheets. So due to this property of conversion of metal into sheets, we can easily use them in making foils. An example of such kind of metal is aluminium foil. Now write uses of aluminium foils. As I told you, due to the high malleability nature, we use them in making foils. And aluminium foil we are using in our kitchen for wrapping chocolates and foodstuffs and to prepare oxygen. So these are the uses of aluminium foils. Now next question is, you have to give reason why zinc oxide is considered an amphoteric oxide. As you know that amphoteric oxides are those which have both the characteristics of acid and base. So zinc oxide, aluminium oxide, they are considered to be amphoteric in nature because they exhibit property of both acid and base. That's why we call them amphoteric oxide. Second is, non-metals in general do not displace hydrogen from dilute acids. If you remember, I have explained this reasoning question when we were discussing chemical properties of non-metals. See, non-metals do not react with dilute acids because they cannot displace hydrogen from dilute acids. Next is, metals conduct electricity. See, metals have the tendency to conduct electricity or to allow electricity to pass through them due to the presence of free electrons in them. So these free electrons allow the current to flow in the metals. That's why we use metals for making utensils, because they are the good conductor, and that's the reason we use metals in making electric wires like copper and aluminium, because they are good conductors of electricity. So this property of metals which make them good conductor of electricity, we makes them suitable for making wires and utensils because they are good conductors of heat also. Now next question is, by what processes do you concentrate the following ores? It means you have to write the method which is involved in the extraction of ores from there, concentrate the ores from there, this ores which are present in the nature. First is PBS, which is known as galena or lead sulfide. So as you can see here, lead is associated with sulfide. So for sulfide ores, we use flotation process. So we can extract or we remove the impurities, and which we call GAN. So we are removing impurities from the ores, and these methods we are using. Now second is Fe2O3, which is hematite ore of iron. So and it is used with the method which we use for the separation of magnetic from the non-magnetic impurities is by magnetic separation. So here we are using concentration of ores. It means we are removing impurities from the ore, and these methods are involved in the separation. Now aluminium hydroxide, which is bauxite ore, it is concentrated by leaching process, which is a chemical method. It means chemicals are involved. So when we are treating this bauxite with NaOH, then it results in the formation of aluminium. So these are the processes which are involved in the removal of impurities from the ores which exist in nature, because we know that the ores exist in nature with some certain impurities which we call them GAN. So ores are those minerals from which we can extract metals profitably or at a very high rate. These are known as ores. Next is sodium, potassium and calcium metals. They form hydrides by combination with hydrogen gas, but most other metals do not. See why these metals form hydrides but not the other one? Because they are highly reactive metals and they easily, force the hydrogen atoms to accept electrons. When they are giving electrons, these are highly reactive, they are electropositive, and due to their highly reactive nature, they force the hydrogen atom to accept electrons which they are losing or they are providing, and as a result of which they form hydrides. The next is aluminium, easily combined with oxygen, but still it can be used for making kitchen utensils. See, aluminium combined with oxygen, it forms aluminium oxide, which is a protective layer. But due to the formation of this oxide layer, it protects the other aluminium to get to prevent it to get corroded. So this aluminium layer prevents the other aluminium to come in contact with oxygen. That's why we use aluminium for making kitchen utensils. So I hope these questions are clear. And the next question is, now you can see all these are reasoning questions. These are concept based questions. Copper vessels used in homes are found to be coated with green color. When we keep on using copper vessels, so some green color layer is formed on those vessels. Now on that basis, what is the chemical composition of the green coating? Why do copper vessels form such a green coating? What is the name of the phenomenon responsible for the green coating? And copper vessels are best cleaned with tamarind or lemon juice, but not with soap. Why? So these are the questions based on this observation. And first is chemical composition of green coating copper. So when the copper comes in contact with oxygen, it forms copper oxide. And then this is the formula of copper carbonate, which is green in color. Then why do copper vessels form such a green coating? Because copper forms green coating of basic copper carbonate when it reacts with water and atmospheric oxygen and carbon dioxide. Because these three things are present in nature. So when copper comes in contact with these three things, it forms a green coating. Then the phenomena which is responsible for this is corrosion. And copper vessels are cleaned with tamarind or lemon juice, but not with soap, because this copper carbonate, which is formed as a result of a reaction of copper with water, then oxygen and carbon dioxide, this copper carbonate is basic in nature. And if we are using soap, which is also basic in nature, so it will not be able to clean it. So that's why we require some acidic substance. And tamarind or lemon juice contain acid in them. And these acid react with this base, then neutralizes the effect of each other, and as a result, copper vessels can be cleaned. And how many carats is pure gold? Pure gold is made up of 24 carat, and this 24 carat gold is quite very soft, and if we'll use it in making ornaments, these ornaments can easily break or we can easily fold them. So that's why we use copper or silver to improve its durability and strength as well. So that's why you people have seen that sometime in gold it is mentioned 22 carat or 18 carat gold. So 22 carat gold means it contains some amount of like 22% is gold and 2% is either silver or copper. And if 18 carat means, it means, sorry, 20% is gold and 22% is silver. So if we are talking about 18 carat, it means only 18% is gold. Sorry, here it is 22% only. So it means only 18% is gold, and rest of the percentage is either silver or copper. And generally you people have seen that when you go to a jeweler, they always recommend diamond jewelry in 18 carat only, because diamond considered to be the hardest substance known, and it needs some solid base so that it can easily fit. So that's why we take only 18 karat gold so that that diamond can easily be fit into that strong gold. And name the metal which is used for galvanizing iron. Answer is zinc. That process is known as galvanization. To prevent the iron from rusting, we deposit a layer of zinc over it, and that process is known as galvanization. So what is meant by 22 karat gold? As I told you, 22 parts of pure gold and 2 parts of copper or silver. Now next is, why do we apply oil on tools made of iron while storing them? So as you know, when the iron comes in contact with oxygen and water which is present in the atmosphere, it shows rusting. To prevent that iron from getting rusted, we always apply some oil or some paint or grease, because they act like a protective layer over an iron metal to prevent it from rusting. Now next question is, what happens when zinc carbonate is heated in the absence of oxygen? See, if it is heated in the absence of oxygen, then zinc oxide and carbon dioxide is formed. And a mixture of copper oxide and copper sulfide is heated, then it results in the formation of copper and sulfur dioxide. So these are the reaction which takes place when zinc carbonate is heated in the absence of oxygen, or copper oxide and copper sulfide is heated. Now another important question is, electric wires are covered with rubber-like material, because rubber is an insulator, which means it does not allow the current to pass through it, because it does not have any free electrons. That's why we use rubber or plastic over the wire to cover the wire so that will not get current. That's why we use rubber. Now next is, from dilute hydrochloric acid, zinc can liberate hydrogen gas, but copper cannot. See, copper is being more reactive than hydrogen. It can easily displace. If you remember reactivity series, the metals which are placed above hydrogen, they are highly reactive than this hydrogen. So they can easily displace it. But copper is placed below hydrogen in the reactivity series. It means it is less reactive than hydrogen. So less reactive cannot displace hydrogen. That's the reason that zinc can liberate hydrogen gas, but copper cannot. Then what is an alloy and how is it prepared? Name the alloy which is used for welding electrical wires together. Alloy, generally it is a mixture of 2 or more metals or non-metals. And the purpose for making alloy is to enhance the durability or strength of the metals, so that their life, we can increase their life. So that's why we make alloys. And how is it prepared? They are prepared by mixing metals in their molten state. And name the alloy which is used for welding electrical wires. Soldier is an alloy which is used for welding electrical wires. Other alloys are brass, bronze, the amalgams. These are the different alloys which we use in, and steel also, on daily basis, so that will increase the durability of the metals. Because if we use iron vessels in our kitchen, so they will get corroded very easily, because on daily basis we are cleaning our vessels, and if there is that iron comes in contact with water and the oxygen, it results in rusting. That's why we use alloys. So iron can be used with any other metal to make steel, so it enhances the durability. And explain how the following metals are obtained from their compounds by reduction process. As you know that in reduction process, generally we heat them alone, and if we are heating them, then we'll get these metals, and on the basis of their reactivity we'll do this process. First is metal X, which is low in reactivity series. If any metal, suppose X is given, which is low in reactivity, so how can we obtain from its reduction process? This can be obtained by heating their compounds. An example of such kind is iron. So when it is heated, when we are heating its ore, then it results in the formation of this mercury and sulfur dioxide gases evolve. So here we are heating mercury sulfide, which is a cinnabar, which is an ore of the mercury. Next is metal Y, which is in the middle of the series. So metal which is middle in the series, they obtain by heating compound with some reducing agent. If you remember, I have explained in previous class, we use carbon or aluminium as a reducing agent. So those metals which are placed in the middle of the reactivity series, for them we use some reducing agent such as carbon or aluminium. An example of such kind is iron. If we heat iron oxide in presence of carbon, it results in the formation of iron and carbon dioxide gases evolve. Next is metal Z, which is high up in the reactivity series. So here, as you can see, X, Y, Z metals are given. They have not mentioned any particular name. So you can take any example. So metals which are high in the reactivity series, we can be obtained by electrolytic reduction, because they are so reactive in nature. So if we'll use any reducing agent with them, they'll react with each other and will not get any pure metal, we'll get some other compound. So that's why we get these metals if we'll perform this electrolytic reduction. For example is sodium is obtained by electrolytic reduction. If we'll take sodium chloride, will pass the electric current, then at cathode and anode, two type of reaction takes place. So sodium and chlorine, they'll get separated by passing current or electricity through them. Next is in the formation of compound between two atoms A and B. A loses 2 electrons and B gains 1 electron. What is the nature of the bond between A and B? Suggest the formula of the compound formed between A and B. On similar lines, explain the formation of MgCl2 molecule. Then we have common salt conducts electricity only in the molten state. Why? And why is melting point of NaCl high? So these are different questions. They are generally comes in 1 mark or 2 mark. So let's do these questions one by one. First is in the formation of compound between two atoms A and B. If A is losing electron and B is gaining 1 electron, what is the nature of the bond between A and B? If you remember, I told you about formation of ionic compounds. So in ionic compounds, one metal or one element loses electron, because metal always lose electrons. That's why they are electropositive in nature. And when they are losing electrons, they attain positive charge on them. So when one element loses electron and one atom gaining electrons, the atom which is gaining electrons, it becomes electronegative because it is accepting electron. And the bond formed between these two is known as ionic bond. So nature of bond is ionic bond and ionic compound is formed. If the question comes what type of compound is formed, then we'll say ionic compound is formed. Okay, then we have suggest the formula of the compound formed between A and B. So you can say like this. This is the formula of compound formed between A and B. Now look here how this formation takes place. A is losing 2 electrons and B is gaining 1 electron. It means 2 chlorines are involved. So if A is losing, it means 1A is there, Mg. Okay, Mg formula is, atomic number is 12. Electronic configuration is 2A2. And if 2B are here, so it means it is giving 1 electron here and 1 here. So the formula is A2 positive and B2 negative. Or we can write AB2. So this is how we'll represent in ionic bond formation. I'll write here Mg is 2 and C. 1, 2, 3, 4, 5, 6 and 7. One more. 1, 2, 3, 4, 5, 6 and 7. So it means it is giving one electron here and one electron here, which results in the formation of Mg2Cl2, but we never write down like this. We'll write MgCl. Okay, because if these are common, so we can cancel it, and whenever we are writing any compound, so we'll not write their charges, we simply write MgCl. Fine. Now, next question is, common salt conducts electricity only in the molten state. Why? See, in the molten state, it carries charges, which are positive and negative charges. As I told you, when one element, one atom gives its electron and the other accepting electron, the one which is accepting electrons, it has negative charge, and one which is giving electron, it attains positive charge. So if we are talking about NaCl, electronic configuration of sodium is 281 and chlorine is 287. And how we can represent them in the form of ionic compounds? Na, this is 1 electron, and 1, 2, 3, 4, 5, 6 and 7. So it is giving 1 electron. Now it is giving, it becomes Na positive, and it is accepting, it becomes Cl minus, negative. So in its molten state, it has ions, but not in solid states. That's why it conducts electricity in molten state only, not in solid state. And why is melting point of NaCl high? Because when we get NaCl after the formation of this ionic compound, this NaCl has a strong bond between them, because it is bonded with this ionic bond, which is very considered to be, the bond between them is ionic bond, which is a very strong, and due to this strong bond, they have strong forces of attraction. So that's why their melting point is quite high, because it needs high temperature to overcome this bond or to break this bond between them. So this is the question. Now next is, why does a metal not release hydrogen gas on heating, or on reacting with dilute nitric acid? See, as we can say that nitric acid is a strong oxidizing agent. If you remember, I explained this exception. So nitric acid is a strong oxidizing agent, and it oxidizes to release hydrogen gas to water, and itself get reduced into these gases. Now next is, why is copper used to make hot water tanks whereas steel is not? Copper is a metal which is a good conductor of heat and electricity. Steel is an alloy. It is an alloy. So when we make alloy, its melting point reduced, its rate of conduction of heat and electricity get reduced. So that's why copper is a best conductor of heat, whereas steel does not. That's why we use copper in making hot water tanks. Then next is, why do the non-metals not displace hydrogen from dilute acids? Because non-metals are the electron acceptor. They are not giving electrons. As in case of chlorine we have seen. So they cannot give electrons to hydrogen ions of acid to reduce them to hydrogen gas. That's why they will not displace hydrogen from dilute acids. Now next question is, define amphoteric oxides and give 2 examples of such oxides. Amphoteric oxides are those oxides which acts like both acid and bases. An example of such kind of amphoteric oxides are aluminium oxide and zinc oxide. Now children, you can see these are very important questions, and you have to represent your answers like this. Now next question is, a metal M is found in nature as its carbonate. It is used in the galvanization iron. See, from this we get an idea which metal it is. Because for the galvanization, we use particular metal. If you know the name, write down in the comment box which metal we use for the galvanization process. So here you need to identify M and name its ore, in which form it is exists in nature. How will you convert this ore into free metal? Free metal here means the pure form of metal. So here M is zinc metal, because with the help of this hint, we get an idea that zinc metal is the M1. And zinc occurs in nature in the form of zinc carbonate. And this can be extracted by, first we heat this in the absence of air by the process of calcination, which results in the formation of zinc oxide and carbon dioxide gas is released. Because you know that whenever calcination process takes place, carbon dioxide gas is evolved, and this once it converts into zinc oxide, because it is easy for us to extract metals from their oxide form. So this zinc oxide then treated with carbon, which is a reducing agent, and then we get zinc, and this carbon combines with oxygen, which results in the formation of carbon monoxide. So this is how we'll extract zinc. Now explain the formation of ionic compound NaCl. See, if we are saying ionic compound NaCl. So first of all, you need to know what is the atomic number of Na, which is 11, and chlorine is 17. So it is 281, 287. And here Na. So this one electron which is in the outermost shell represented by this X, and in chlorine valence electrons are 7, 1, 2, 3, 4, 5, 6, 7. So this sodium transfer its one electron to chlorine, and as a result it attains positive charge, chlorine attains negative charge, and then we'll get this ionic compound. So this is how this ionic compound is formed. Or another example of this is magnesium oxide. So we know that magnesium, its atomic number is 12, and its electronic configuration is 282. Oxygen 8, its electronic configuration is 26. So children, if you'll write ionic compounds, you should learn their atomic number, then only you'll be able to write their electronic configuration. It will then, because once you write their electronic configuration, it is easy for you to make ionic bonds between these atoms. Now I'll write magnesium, outermost valence electrons and of magnesium is 2, and outermost valence electrons of oxygen is 6. So I'll represent this with these two crosses. So these are valence electrons, and here it has 6. 1, 2, 3, 4, 5, 6. So it will give its 2 electrons to this, and it is giving 2 electrons, it is accepting 2 electrons, and it becomes MgO, which is magnesium oxide. So this magnesium oxide, it is a layer which is formed on the magnesium when it comes in contact with oxygen, and when we burn magnesium ribbon, we always remove this layer, magnesium oxide layer, so that we can easily burn it. So now these are the questions which are very important according to exam point of view. Apart from this, there are certain questions like, for example, questions can come on the basis of extraction of ores, like they'll ask explain the calcination or difference between calcination and roasting, or the question can come describe the process of froth flotation process. Then you have to explain the entire process of froth flotation, So in the flotation process, you'll need to draw this diagram in which we use this agitator which has some holes in it. So through this agitator, compressed air is passed, and this is done in sulfide ores. Sulfide ores. And in this tank, we take pine oil plus water. So this is the ore which is present in it, which is present with sulfide. Okay, now when we pass this compressed air through these holes, this compressed air goes in this sulfide ores, and these sulfide ores start attracting toward the pine oil and the other ore. See, the ore which is exist in nature in its sulfide form. Okay, and the impurities combine with water. So when these sulfide ores combine with pine oil, it becomes lighter in weight. And when they are lighter in weight, they comes on the surface in the form of froth. These are sulfide ores along with pine oil plus pine oil. Being lighter in weight, they come on the surface and keep floating. And here, impurities mixed up with water and collected here. So this is flotation process. Or question can come, explain magnetic separation, or how will you separate magnetic substance from non-magnetic substance. Then in that case, you'll explain with the help of this diagram in which magnetic roller is present. This is magnetic roller in which magnets are present, and here these ores are, we pour the ore and magnetic substance make a heap here, and non-magnetic impurity, it will move like this. Non-magnetic impurity will deposit here. So this is the magnetic separation technique. This is known as magnetic separation technique, which is used to separate magnetic and non-magnetic substance. Then after this, now tell me, what is the formula of or name the ore of iron. Write your answer in the comment box. Name the ore of iron, zinc, copper, iron, zinc, copper, and mercury. So if you know the answer of these metals, the ore of these metals, write down in the comment box. Write down the name of the ore along with their formulas. So these kind of questions can come in exam. Apart from this, what will happen if copper react with AgNO3? Or if silver react with copper sulfate? Now write on your answer in comment section. What will happen, or what kind of reaction can take place if these two substances combine together? Okay. Now, copper being more reactive than silver, it results in the formation of copper nitrate and silver is left behind. Now in this one, no reaction takes place because silver being less reactive than copper, it cannot displace copper from its salt solution. So these are the reactions takes place when these two react with each other. Now write down the difference between roasting, it is very important question children, and calcination. How can you differentiate between them? So just write down the answer in the comment section how they are different from each other and what kind of ores what kind of ores are involved in these two processes, roasting and calcination. If you know the answer, write your answer in the comment section. So these are the questions according to exam point of view. Go through this chapter thoroughly. It is extremely important chapter and questions can come in 1 mark, 2 mark, 3 marks and 5 marks as well. So if you have learned the chapter thoroughly, you'll be able to write the answers. Concentrate on reasoning questions so that you can easily write down the answer if the conceptual questions can come in exam. So I hope this chapter is clear to you. Until then, goodbye and take care. So in next class, I'll start with new chapter. So till then, goodbye.